So today's topic is statistical analysis, okay? Statistical analysis is used to calculate mean and standard deviation. Also the t-test and correlation between data sets. Maybe these words are new for you, but we're going to understand how to calculate that type of data and how to analyze from that statistical analysis that we're going to use. Okay, so the first thing that we need to understand is correlation and causation, okay? One of the most common errors is the confusion between these two words. In theory, these are easy to distinguish. Remember, distinguish the differences, right? Okay, an action or occurrence can cause another one. For example, smoking causes lung cancer, right? That is a kind of correlation, such as smoking is correlated with alcoholism is another one. But when we have causation, is if one action causes another one, okay? But because just two things occur together doesn't mean that one caused the other one, even if it makes sense. For example, correlation describes the strength and direction of a linear relationship between two variables. The correlation, because they are correlated. It's positive or negative. I'm going to show you in graphs how a correlation could be positive or negative. Causation, by the other hand, describes the relationship between two variables, where one variable has a direct effect on another one. Okay? So we're going to understand this in class. I'm going to explain with examples. But this is one causation. CO2 levels and crime have both risen, right? But CO2 levels don't cause crime. Then we have the first word, mean. The sum of all data points divided by the number of data points is the mean. You know that. Promedio, okay? You know how to obtain that. Measure of central tendency for normally distributed data. Okay, so in these pictures you have examples of correlation. In this one you have a strong positive correlation, as you can see. I want you to see those pictures and see the difference between those, okay? A strong positive correlation because the data follows a pattern, and the data, as you can see, those points is data, right? They are data. They are following a linear direction, as you can see here. That is a strong one when you have all the points close together. Positive correlation when we have all the data points. They're almost close, some of them are far from the central tendency. Then we have a negative correlation. It's the change of direction that you can see here. Strong, because they're following the pattern. Negative, they're almost the same, but in the opposite position, okay, if you obtain your data. So you obtain your data, you have two variables, you have to draw the points, and then you're going to find if there is a correlation. Remember, smoking causes cancer. So this type of chemical improves the germination of seeds. So you can use this one if you want to do it. And if in your data, the data that you obtain, you have this kind of set of the data, there is no correlation. Okay, maybe use a chemical that is not going to affect the correlation of seed germination. So that is correlation, okay? Then we have a standard deviation, and it says average don't tell us everything about a sample. When we talk about average, we are talking about the means, right? Samples can be very uniform with the data, all bunch around the mean, or they can spread out along away from the mean. So this is the mean here. If they spread, we have points far from the mean. That is part of this standard deviation. As I told you in class, okay, if I determine the height of all of you, okay, so the average is 1.7, okay, meters. But I don't know, one student is going to measures 1.8 meters, and another student measures 1.5 meters. So the standard deviation is the plus or the more or less sign that you can find in many different studies. So more or less, 17 centimeters. So that is the difference that we can find in a group of students when we talk about height. Okay, the same happens when you are doing an investigation. You're going to find that all organisms behave in a different way. Okay, we have samples can be very uniform, but in some cases they are very long away from the mean. The statistic that measures this spread is called the standard deviation. Okay, this is spread, how the data is spread. The wider the spread of scores, the larger the standard deviation. So Higher standard deviation, that means that the data is very spread, okay? For data that has a normal distribution, 68% of the data lies with one standard deviation of the mean. But why do we need to calculate this standard deviation? Because that way we're going to see that the experiment is well done. If we have a high standard deviation, that means that we have data that is not following the patterns, okay? In class, we're going to do an exercise of how to calculate the standard deviation with a table with data. We're going to apply this formula. It's not that difficult. Maybe you already know how to do it in your calculator because Paquito told me that you know how to do that. Okay? So what can you tell me about this picture? Sorry, we just can't trust you. Why? We have different bars here, right? This is a graph. We have the y-axis, the x-axis, and we have different data. This is the mean of that data, almost 75. Here, 20, it could be 35, something like that, almost 50. But what is happening with this bar that is showing here? That is the standard deviation or error bar. So it's too high, and that means that the data that was collected in this experiment is not following a pattern. Okay, so something is happening. Maybe it's not affecting, it's too high, the data is too spread. Okay, that is not good in science. Then we have the student t-test. That is another thing that we're going to study in class. It's another statistical test that compares the mean and the standard deviation. Again, I'm going to compare this with this. What for? To see if there is a significant differences between them. In an experiment, a t-test might be used to calculate whether or not differences seen between the control and each experimental group. Remember, control, if you just use distilled water, that is a control, but if you use different chemicals in that water that are going to improve seed germination, that is a treatment, okay, that you are applying. And the control is just distilled water, right? And we can see which is the difference with this student t-test. Again, in class, we're going to learn how to calculate the t-tests between two different groups. And that way you're going to have a clear idea of what can you do. Do you want to compare in your internal assessment? Do you want to see if one variable is affecting another one? So we're going to learn which one do you have to use, okay? We're going to do this in class, how to calculate t. We're going to follow the different steps. And we're going to use this also. I'm going to teach you how to use this table to do that. Remember that we need to remember what is data, right? Could be called data or data. Information in the form of facts, figures obtained from experiments or surveys used as a basis for making calculations or drawing conclusions. That is data. Statistics in science, data can be collected about a population, surveys, or maybe about experimentation, right? There are two types of data: qualitative, information that relates to characteristics or descriptions, observable qualities, I know, high, green, that is a quality, okay? And then when we talk about quantitative, we are measuring something, okay? I want to measure the length of a plant, I want to measure how many spots, I want to count how many bacteria can we find, so that is a numerical score. Descriptive is the description, right? We need to measure in the spread of data. Again, spread, okay? You can use the term significant. So we have average, you know how to calculate the average or mean, range, standard deviation, and the standard error. So those are some of the things that you can use. Also, we need to know and learn what is chi-square, student's t-test, that is the most common use in science. And I'm going to teach you this in class, okay? I have a PowerPoint presentation to teach you this in class again because it's a topic that it's not that easy. And we're going to do exercises in class also. Thank you, guys.